Okay, ladies and gentlemen, now let's take a look at examples of proving trig identities. What you want to remember to do when you prove trig identities is you want to get both sides equal to each other. It doesn't matter how they look as long as they're equal. And I think the easiest way to get them to be equal, there's many different techniques. I'll convert everything to sine and cosine, and then I'll start turning more things into less things. If I have two things, I'll combine them by multiplying. If I have two things divided, I'll flip them and combine them. Let's try a couple together. Let's look at the first one. You can have your sheet in front of you because you have those relationships. Well, I know cotangent is equal to cosine. I'm going to leave off the x's for now, over sine. And tangent is equal to sine over cosine, which is equal to, it says it's equal to 1. I cancel these, and I cancel those. I get 1 equals 1. Piece of cake. Simple. Keep that in mind when you're working on problems. You're just canceling things out, simplifying and canceling. Let's take a look at this one right here. This is 1 over cotangent is equal to cos over sine. Now I'm going to write everything as a fraction. It just seems to be easier. Cosine is already in cosine, so that's cosine over 1 times tangent is sine over cosine. All of that is equal to 1 over cos. So now I'm going to look and see if anything cancels. Oh, here's a cos and a cos. Here's a sine and a sine. I'm left with 1 over cos equals 1 over cos. So I've done it again. All right, this is pretty easy so far. Let's try another one. Let's try this one right here. Let's convert everything to sines and cosines. Secant is 1 over cosine. Cosecant is 1 over sine. All of that over. Cotangent is cosine over sine equals 1 over secant is cosine squared. Once again, I left off the x's while I'm working on it. If I look at this now, it looks to me like I got a big, big problem. I got all of this stuff here and all of this stuff here. I don't want all that stuff there. I'm going to try to simplify things to make them into less things. First thing I'm going to do is I'm going to combine these two things into one fraction, taking two fractions and making one fraction. So let's undo that. And it's going to become, erase that, 1 over, oh, that's a highlighter. Where are you, purple? 1 over cosine times sine. Okay, so now I have the format I like to have it in, which is I have one big fraction over another big fraction. And what I'm going to do is I'm going to simplify that the way you guys used to do it all the time back in 5th and 6th grade, which is if you have one fraction, 1/2, over another fraction, 4/3, you can change it to multiplying by keeping the top and multiplying it by the flip of the bottom. So I'm going to do it with this one. I'm not going to erase it. I'm going to do this one over here so we can see it. So the top is 1 over cosine times sine times, I'm going to flip this, 1 over, oh, said 1 over. Nice try. Flip it to sine over cosine equals, let me write this part down, 1 over cosine squared. Let's see if anything cancels. Cancel, cancel. I've got 1 over cosine squared equals 1 over cosine squared. I got it again. So the pattern on these is all of these are just multiplication. And when it's just multiplication, there's always a lot of cancellation that goes on. They're pretty straightforward and pretty easy. Let's try one more. Let's try this one right here. 1 over sine times sine over x. All of that, oh, I made that over 1 over 2 equals 1/2. These all cancel. This becomes 1. I got 1/2 equals 1/2. Okay, good job. Well, now let's look at the other type of problem that could happen. As soon as we see that addition or subtraction is in play, we have to do something a little bit different. Let's see if we can find what addition and subtraction is. I don't see anything there. I don't see anything here. No, I got one. Where is it? Oh, there it is. Okay. Here we go. So I have two separate terms here. I'm going to turn everything into sine and cosine. So this is going to be cosine over sine plus sine over cosine equals 1 over sine times 1 over cosine. So the technique to do when you have adding and subtracting in there is you're going to do the following. Much in the past, if you had to add 1/2 plus 1/5, how would you do that? Well, you would find a common denominator. And it's really easy to find a common denominator. You multiply this one by the 5 from the other side, multiply this by the 2 from there, and you get 5 over 10 equals 2 over 10. Oop, not equals, plus 2 over 10. Then you can add. The 10 is the bottom, and you add the two numbers on top. 5 plus 2, 7 over 10. So that's taking two terms and turning it into one term, and that's what we're going to do here. We're going to do that for when we have this adding here, but what I've got to do is get a common denominator. Don't go crazy thinking about it. I'm going to multiply this one by cosine on the bottom and by cosine on the top. Okay, I'm going to multiply this one over here by sine on the bottom and by sine on the top. Now I'm going to multiply things out. So I'm going to add them together. The denominator here is going to be sine times cosine. And on the top over there, I've got cosine squared plus sine squared equals 1 over sine times cosine. Okay, so let's take a look and see if anything else makes sense of how to do it. If I look here, the bottoms are the same. Now let's take a look at what the tops are. Here it says sine squared plus cosine squared. Look on your identity sheet. Do you know what that's equal to? It's equal to 1. So we have our statements here. Sine cosine, 1 over sine cosine, and we're done. Got them equal. The last type is when you're going to see two things multiplied together. There's addition, but there's parentheses here. We're always going to FOIL first, and hopefully things cancel out. First, 1 times 1, outer, negative cosine x, inner, positive cosine x, last, plus cosine squared equals sine squared. Everything's in terms of sines and cosines. These will cancel. Now take a look at what we have. 1 plus cosine x. Oops, did plus. Right. Gotcha. 1 minus cosine x equals sine squared x. I left the x off, I know. Take a look at your sheets, and you'll notice that is an identity. You've listed on the Pythagorean ones. You can just put a check there. If you need to go one extra step, you can say this is equal to sine squared x equals sine squared x. Got a check mark. Okay, so in terms of problems on tomorrow's quiz, there's going to be 4 to 5 to solve. 4 to 6 to solve. Most are going to be all multiplying, but there may be 1 or 2 like these right here. Okay, give it a shot. Take care.